All right, Socket.io and Mongoose. We're talking about Mongoose. We're talking about a wrapper. That's basically an object document model wrapper on top of your MongoDB, like we talked about MongoDB, that NoSQL database that was so great and so flexible and schemaless the other day, and how we can work with that and some of the limitations around that. Um, but this basically allows you to create a wrap around that to let it interact with Node.js in a better way, in C# or .NET or Java in a way it's all objects. So we want to maybe, instead of using the Mongo driver natively, we can use something like an ORM, which gives us the not only the document or the object, but also a whole bunch of features attached to it. So there's definitely a benefit for using this kind of thing, and we'll take a look at it. So we're going to find out what Mongoose is. We're going to find out schemas and models. We're going to talk about some CRUD operations and queries. And first we're going to find out what a Mongoose is. So I didn't know what it looks like, to be honest. I had to look it up. So this is what a Mongoose looks like. Apparently they can stand up, and they're in Eurasia. I didn't know that. So fun fact, I guess. It amazes me. Developers always come up with great things. It's probably better than just calling it a document mapper. We're going to call it Mongoose, and it's used for object modeling. Again, it's middleware to the MongoDB driver. So if we haven't talked about Express yet, you know that middleware is kind of like that middle in the pipeline between the request and response. There's a middle, and that's where it sits in the middleware. Actually, before the response hits the server, you can do a bunch of things, kind of intercept that transaction and do a bunch of things in the same way that Mongoose does that. So from the application server to MongoDB, we have this middleware that does some wrapping for us and returns some nice objects with a bunch of features onto it. That's what it does. Don't pay attention to that diagram on the left, although it does go through that kind of pipeline there, that object mapping. It looks like it's coming straight from the database itself. It's going to go through Mongoose to do some of that mapping. But remember, it's not an ORM. It's not an object relational mapper that returns objects. It returns documents, because that's what we're talking about here. We're talking about documents. But it provides features that MongoDB doesn't: validation, defaults, query binding, pseudo joins. A lot of, again, we said there's no inner joins on this kind of table because it's NoSQL. But how it does joins is you might have a massive data structure like a DNA kind of, some kind of markers or something like that. If you worked in the medical industry, you'd have all of this nested within a document, but nested. So every relationship you might need is nested inside of a massive document. So there's no real need to do joins, but there is a way to do pseudo joins with Mongoose using some keyword called lookup. It's not what you. It's a little complicated and it's more advanced that we're gonna get into. Lifecycle management really great. So if you do like a pre-hook and a post-hook after saving, you can tie into those and do a bunch of stuff. So that's really great. So using it's really easy. You do use the npm install mongoose save. You walk up and require it into your project, and then you connect via uh, local driver, your local MongoDB local on your server, on your local host, or you can use some cloud server like Cloud Atlas, Mongo Cloud. Is that the movie? I think it is Mongo Atlas, and you can get the connection string there. So when we're talking about Mongoose, we're talking about schema and models, and remember you got to remember this, that everything in Mongoose starts with the schema. The schema maps the to the database collection. It maps the document almost exactly. It's basically a wrapper around that. It defines the shape of the document. So you start with the schema. In this example here, you do a very simple customer schema, and you do a new schema, and then you basically on each property define the type. This is a very flat schema, but what we want to do is after that we use this one line here that you'll see everywhere. This is like the special sauce: mongoose.model, the name, and then the schema. This is what you need to return that wrapper that you can then use throughout your application. You're going to see this everywhere. This is a little bit bigger example. So you can have all these data types on there. Again, the schema is the shape of the document. Of course, you have string, number, date. Buffer is something new to Node.js. That's a primitive type it added. Buffer is like a storage space for things like streaming and things like that, where data can store in this physical unit of memory within Node.js. It's a new kind of data type. Buffer mixed object ID and array. And here we just have a very simple flat scheme on the side here. It has name, student ID, and we say flat meaning one level, and there's not too much. It's just the property itself. Once we do that, we set up the local the simple schema, and then we export that out to the world to use. More complicated schema here is something that's more nested. So here you can have different levels of nesting. So here we have a parent schema, which is the student down here, and we have name and first name. Here it's a JSON object, but you notice here in the address there's an array. So we have this child array. We basically extracted this out for clarity, and we can actually define it up here and then plug it in at the bottom here, which is great. And if you see once that little panel kind of gets out of the way, it's a little annoying. You'll see that there's a default, and it's is active, is true, is defaulted to true. So that's really great. You can default it and you can mark things as required. And again, you can have very many levels of nesting here because we're our relationships. We don't use foreign keys here. We use nesting. So the model itself. So when we create the model, and what's really great about the model is that it's very flexible. Again, we'll note that it's a wrapper around the schema to provide CRUD interfaces. Just know it's a very high order constructor that you give it the schema, you create an instance of it, and it creates that document that's equivalent to records in the relational database. But when you create the model, you give the model name and the document schema. The model is basically dynamic in the sense that when you create that model, so here we have this schema model, the student schema, we define it, we instantiate it, and now we have a student model. But what's great about it is then you can reuse that schema, add on the fly another property to it. So here we have the student schema, we add another property called is international, and then all of a sudden when we have a new model called international student model. So in a way, we can recycle and reuse our schemas all around, and we have instance of models based on that schema, and then add to the schemas. So you might have a product list, and you might have a product, and then you extend it out to say, I don't know, some type of shipping product, or like inventory product or something like that. It's basically like classes, and you can derive classes from base classes, if you know your object oriented programming. And we just want to note that a document is an instance of a model, and we can have multiple documents per model, right? And we can also have subdocuments, many subdocuments per document. So what that means here is on the left there, we have a student named Captain Jack, Pirates of the Caribbean, right? His address is in Jamaica, and we have that one address. But on the right here, you can see that we have an array of addresses. We create the address here, and then we push it into the array. And that means that we can add multiple addresses, 10, 20, and then we take that array and we push it into the main parent instance of the model, which is right here. So we're basically saying that we can have multiple subdocuments because that address is a subdocument, and now we have a little bit of nesting going on. All right, so before I get into the CRUD documents, let me just quickly look at an application I quickly did. So I'm not talking all about just, so I'm showing some code here. So if you can see here, if you install your local driver, you're going to have MongoDB serving. You need to kick off this Mongo daemon, so that it's running in the background, so you can actually work with the shell. So that's not the shell. I'm sorry. Here we are. So this is the daemon here running, and then I can look at this thing called Mongo Compass and take a look at my database. So I have something called restaurants from a previous example, and it has a bunch of data in it, and that's what I'm going to return. That's my goal. I'm going to return. So on this document, I have city, cuisine, and name, and I'm going to go ahead and I'm going to query that. So what I did um, is I created this app already that I basically showed already, and I reused it from another app. When I click, I have these for a later example. I'm going to place an order. I'm going to get orders. But what I want right now is I want to trigger from here using Socket.io. And if you haven't used Socket.io, it's a great little tool for a TCP/IP connection. I really like it because it's really great. And anyhow, I can trigger get restaurants, and in the back end, it's going to go ahead and it's going to go and call the backend server, and it's going to return a list of data. So first thing I did is I of course did npm install. I grabbed Mongoose and I installed it. It's in my package.json, and then I created this schema here. And let me check my battery here so it doesn't die. All right, 20%. I guess that's good. So I went and I required Mongoose, and then I created my restaurant schema. So new mongoose.schema. I created my properties string. It's very flat, so I require that the city is true and it's a string. Cuisine is not required, it's optional. I require a name, and I set an active flag, and I defaulted to the true. And then I did the model mongoose.model, created the model based on the schema, and I exported it to the world to use. So now when I go into my server, I can go ahead and I can bring that model in. That's step one. Well, I guess step one would actually be bringing Mongoose in. So maybe that's not the first step. First step would be bringing Mongoose in. So Mongoose require Mongoose. Then I grab the connection string, which is a local connection string, by the way. This is database name. If you're missing that, you have to do /database. So for me, it's config, which is really weird. Otherwise, I'll throw errors. And then I open up my Mongoose connection. I do mongoose.connect. I have some parameters here, and then I handle the using a promise that it's connected or not. Once I have that connection open, that means I'm connected to my underlying MongoDB, and then I can start using the wrapper, and I can start doing things. Step three, of course, is bringing that model in, which I have. So now I have a restaurant model, and using Socket.io. Again, if you don't know about Socket.io, you can trigger events and you can listen for them and do callbacks. So I'm not going to really go into that as much, but I can tell you that I created this listener in Socket.io. So here, quickly I'll go over it. You listen for this connection. You listen when it establishes a connection on a socket. I can go and listen for a disconnect, and I can also listen for get restaurant. So when that's emitted from the front end, I have a callback function, and I console log out quickly that I got it, and then I have the model dot find. So I don't have any. It's basically I don't have any parameters like that. I don't have any query logic in there. It's basically going to grab everything and it's going to return it. So when it returns it, I have an error first callback, and I grab the documents and then I console log them using a map function. I just grab the name and then I basically emit them back to the front end. And that's using the Mongoose wrapper. I didn't have to write any query logic. I just had it on the map. It knew what the collection was. When I did that find, it returned back to me. And I have all this handling logic, which is really great. It works really well with Node.js. And we're going to look into some CRUD operations next.